Greetings and welcome, students of the world, seekers of wisdom in mathematics. Today we're going to talk about polynomials. Polynomial, by the way, I want to let you know what it is. Polynomial. Polynomial. Poly, prefix meaning many, like polytheistic is believing in many gods. Polygamy is being married to many people, right? Polynomial is a many-termed expression. Many terms, right? Termed, I'm verbizing that somehow. Expression, bam. Many-termed expression, right? So polynomial, examples of polynomials would be like 2x plus 1. All right, terms are separated by plus or minus signs, so those are terms right there. You could have 3x squared minus 5x minus 1. That's a polynomial. You could even have like 2x to the 5th minus 3x squared plus x minus 7. Oh yeah, that's a loop-de-2 right there. Good catch. Man, you guys are good. I should seriously have some hidden gold pieces in my notes, like whoever calls the Waldo. It's like ching, like you just get some gold pieces that are hidden. You like jump up and hit this block like Mario, and then like a little coin shoots out. Ching, like that'd be awesome.
Oh, like a three-sided die, like every day, and then like however many gold pieces, like roll like a 1, and if you call it somehow the water,
Oh, so like the prize varies each day? That'd be interesting too.
100%. The classified kill streaks.
So anyways, there's a couple ways of classifying polynomials. You can classify them by name or degree. So let's see, the degree of a polynomial, or the degree of a term, we'll talk about that first, how about, is the sum of its exponents. I guess its variables exponents, I suppose, would be more accurate. All right, so for instance, the degree of the term 2x, that x is to the first, so this is a degree 1. All right, here's a degree 2, degree 1. Technically, a constant term has an x to the 0 there if you wanted to pretend that, so it's a 0-degree term maybe. Here's a 5th degree, 2nd degree, 1st degree. Stuff like that. So that's what I mean by degree of a term, all right? And some of its exponents, what I'm saying by that is, what if I have this term, 3x squared y plus 2x? This term's degree would be 3, all right, because it's the sum of the variables' exponents. Yes, I guess variables, apostrophe there. So the degree of a polynomial is referring to the highest degree in the polynomial, right? So this is a 3rd degree polynomial, this is a 2nd degree polynomial, 5th degree polynomial, where it's just based off of the highest degree. Then you have the leading term, which is the coefficient of the highest degree term. Well, no, I lied. I'm sorry. The leading coefficient would be that. Sorry, my apologies. The leading term is just the term with the highest degree. The leading coefficient is the coefficient of the highest degree term. My bad. My bad. Bam. Right? Then, let's see, what else do I got? So the leading coefficient here would be 3. Leading coefficient here is 3. This leading coefficient is 2. Leading coefficient is 2. So there's some language for us to be aware of. So classifying polynomials, you classify them in 2 ways, all right? One is by degree, and one is by the number of terms. So let's see. So let's figure it out by degree. So we'll have the name, we'll have the degree, and we'll have an example. Make a little chart here. So this is classifying by degree. So if I have a 0th degree polynomial, that would be something like 2, be a constant, or -7 would be another example, right? The name of a 0th degree polynomial is a constant. And if you think about it, there's no variable attached. Variables vary. Constants stay the same. So if it's lacking a variable, it's going to be constant, right? Let's see, 1st degree polynomial would be like 2x or -3x plus 1, right? 1st degree, right? Does anyone know what these are called? Linear, all right? Because if I was to graph these, if I said y equals 2x, that would be a line with a slope of 2. If I said y equals -3x plus 1, that'd be a line with a slope of -3 and a y-intercept of 1, right? So linear is what those would be. Degree of 2 would be like x squared minus 4 or 2x squared plus x minus 7, something like that. Does anyone know what those are called? Those are called quadratics, which is very deceptive because quad sounds like what? 4, yeah. But it's related to actually a square, all right? A quadrilateral. These often represent the areas of a 4-sided figure. And right, side times side is side squared, so that's where that quad is coming from. Let's see, 3rd degree, 4th degree. We'll hit that. So a 3rd degree is called a cubic, and a 4th degree is called a quartic. Right, so that'd be like x cubed minus x plus 1, something like that, or x to the 4th plus 1, something like that. So those are all names based on the degree of the polynomial. And similarly, there's names based on the number of terms. All right? And I'm just going to go through these quick because we're about out of time. So if there's 1 term, 2 term, 3 term, and then 4 or more. 1 term is called a monomial. Hey, we already talked about that, right? Monomial. 2-termed expression is a binomial. 3-termed expression is a trinomial. And 4 or more is just called a polynomial. So that's kind of weird that all of these are polynomials. Polynomial is like the overarching classification. And then polynomial is also a specific type of polynomials. So it's kind of odd that they have a redundant word. It'd be like if you had the animal kingdom, and then you had mammals, and then under types of mammals, there was like monkeys and dogs and cats. And then what if there was another animal that was a type of mammal that was also just called a mammal? Like, it would be weird that they used the same name twice. So that's kind of what's going on here. But that's an introduction to polynomials. And thanks for watching, internet friends.